Hello students, welcome to School Maths Simplified. In today's video we will learn Chapter 1 a square and a cube of class 8 Ganita Prakash, and the topic is cube and cube roots. Started. Firstly, what are perfect cubes? What are perfect cubes? You are aware of the sequence 1, 8, 27 and so on. So each of them is obtained by multiplying a number by itself 3 times, right? 8 can be written as 2 cross 2 cross. 27 can be written as 3 cross 3 cross 3. In general, for any number n, n cross n cross n can be written as n cube. We use the power p here. Hope this is clear, right? And now I want to tell you about the cube roots. Cube roots. Now what are cube roots? The concept will be same as square roots. In general, if we have y is equals to x cube, then we call x is cube root of y. Cube root of y, and it can be written as x is equals to cube root of y, and this is the radical sign of cube. Now you have to put 3 on the head of the sign of root. Fine. So if we talk about an example for this, for example, 8 can be written as 2 cross 2 cross 2, which can be written in the form of exponential form, that is 2 raised to cube, right? So 2 is the cube root of Find the cube root of certain numbers. We'll again use the prime factorization method. So these basic concepts are clear, so I'm moving to the figure it out question number 1. Question number 1 is find the cube roots of these two terms, 27,000 and 10648. So let's do it. We will do this question with the help of prime factorization, okay? So here we have 27,000. So let's solve it. We get 13500, and on dividing with 2 again we get 6750, and 2 is 3375, 31125, again add 375, again add 3 is 125, then 5, 25, 5. So 27,000 can be written as and here you will see the pattern is existing in triplets, a group of 3. Yeah. So we need to find out the cube root of 27,000. So it will be 2 cross 3 cross 5. So the answer will be 5. As we used to do For square roots, we will do the same thing for cube roots with the prime factorization method, but here we pair them into three or triplets. Fine. Similarly, for 10648, for 106, again, the prime factorization will be 5, 3, 4, 2 it is 2, 6, 2, 2 it is 1, 3, 3, 1, 11, 21, 11. So 10648 can be written as 2 cross 2 cross 2, 11 cross 11 cross. So it is again existing in triplets. The cube root of 1068 to 2 into 11 is clear to you. Moving to the next question. What number will you multiply by 1323 to make it a cube number? The same way we'll use the LCM method. So we have 1323. 323 will be divided with 3, we get 441. Again with 3 we get 147. And with 7 we get 49, will be 3. Get 49 and then 7. 1323 is equals to 3 cross 3 cross cross 7 cross 7. As you can see, only one triplet is existing. There is another, no, 7 is lacking over there, right? So to complete triplet, one more 7 required. So 1323 will be multiplied by 7. We'll get 1323 into 7, that is 9261. 9261 is a correct. Into the next question. Straight or false? Explain your reasoning. The first one. The cube of any odd number is 1. The cube of any odd number is even. Let's take an example for one. For example, we'll do it with contradictory example or with example, right? The reason is false. False, and the reason behind this, cube of any odd number is always odd. It is always odd. For example, is take it 3. 3 is odd number and the cube of 3, that means 3 into 3 into 3 is 27, and 27 itself a odd number. Another example like 7 cube, 7 into 7 into 7, it is 343, again an odd number. Statement is false. Second, there is no perfect cube that ends with is also false. So a perfect cube which is ending with 8, the example of this is 2 cube. See, this is a perfect cube ending with 8. Another example can be 12 cube, is 12 into 12 into 12, which is 1728. See, ending with 8. 22 cube will gives you 10648, again ending with 8. This is the answer of second part. Now moving to the third part, that is the cube of a 2-digit number may be a 3-digit number. Okay, let's discuss it. This is also false. Let me tell you one thing. This is also false. And what is the example for third part? They are saying the cube of 2-digit number is 3-digit number, right? But we have the minimum number, like 10 is the smallest 2-digit number, and when I'm cubing it, so 10 into 10 to 10, we get 100 is having 4 digits. This is clear. What is the question? The question asked here is the cube of 2-digit number may be a 3-digit number. So when we are taking a minimum number digit, we are getting 4 digit, at least 4 digits, right? So false. Fourth one. Fourth one is the cube of 2-digit number may have 7 or more digits. Okay, let's see it. This is also false. Oh, this is also false. So let's do it. Now I'm taking the largest 2-digit number, 99 cube. 99 cube gives you 97029, which is a 6-digit number. This is also false. Lastly, fifth one. Fifth one is the cube numbers have an odd number of factors. This is also false. Cube number which is having odd number of factors. So this is also false. And how it is false? See, take one example like 7. 27 can be written as 3 into 3 into 3, which is odd. Means number of factors are odd. 3 factors are they are odd. An example of 64 can be written as 2 cross 2 cross cross 2 cross 2. Now count the number of factors. They are 1. There also the next question. You are told that 1331 is a perfect cube. You guess without factorization what its cube root is. Similarly, guess the cube roots of these given numbers. Okay. So for this, you are told that 1331 is a perfect cube. Can you guess it without prime factorization? So there's a way to do it. We divide 1331 into 2 groups. We divide it into 2 groups starting from the right, okay? So 331 will be the first group. And we are left with 1, right? This will be the second group. Three three one is having unit digit 1. The unit digit is 1. Hence, cube root of 1 is 1. Cube root of 1 is 1, right? Now for group 2, we have only 1. This is for group 1, first group, right? Now for the second group, we have only 1 here, so which is 1 cube. So cube root will be 1. So 1331's cube root will be 1, 1. We are just taking the unit digit of the numbers and getting their cube roots. Will get two numbers and these numbers be arranged like this at the unit place and tens place, and this will gives us the idea that what will be the cube root of the given number. Let's do it with another example. Like you have to find the second part. Have to find it for 4913. Have to find it for this, right? So again, let's do divide it into groups. So 913 will be our first group. 4 will be in our second group, right? And in the first group, look at here. In the first group, the unit digit is 3. 3 comes at 913. Unit digit 3. And its cube root. And its cube root ends in 7. How do I know the C? 7 cross 7 cross 7 is 343, right? And we are getting unit place 3. तो कब किसी भी नंबर का यूनिट डिजिट 3 कब आएगा किसी भी क्यूब का? जब उसका क्यूब रूट क्या होगा? 7 होगा. Now this thing you need to learn. It will come with the practice, okay? And on the second group, in the second group, 4 lies between 1 cube and 2 cube, right? So 1 cube and 4 is lying between these. So we are taking the right, considering the lower limit here. The tens digit of the cube root is 1. Because there is only 1 cube. So cube root will be 1, right? So taking the lower limit, the tens digit of 1 cube is 1. So the number will be cube root of 70. So moving to the third part of this. Similarly for the third part, 12167. Then first group will be of 167 and 12 will be in the second group. And in the first group, we are having 7 at unit place. So the cube root of 12167 is 3. And for group 2, we have 12 here, which is lying between 2 cube and 3 cube. So taking the lower limit, the tens digit is 2 because we are taking the cube root here, right? So it will leads us to the cube root of 12167, which is 3. And lastly, we have another one, that is 3 to 768. Group 1 is having last digit 8, unit digit 8, which is a cube root. We are getting the cube root at unit place, that is 2. And for 32, this is lying between cube and 4 cube. Taking the lower limit, we have cube root of 3 cube will be 3. Cube root be 3. So this will be our tens place. So cube root of 3 to 768 will be, these are some formulas. So some can say a method without using the prime factorization. Question number 5, you need to find out the difference of these cubes. Before starting with this question, you need to know formula, that is n plus 1 cube minus n cube is always 1 plus 1 into 3n, and n plus 1 cube minus n plus 1 square minus n square is 2n plus 1. These are the two rules that will be helpful for this. I will tell you the proofs of these two rules in the short video, in the next short video. For now, we are using these formulas here for the first part. We have 67 cube minus 66 cube. By using this formula here, the value of n is 66, okay? The n is 66 here. Put the value into this formula. It will be 1 plus 66 plus 1 into 3 into 66. Right? So what is the answer? 1 plus 67 into 3 into 66 is 198. And then we'll multiply 198 with 67. It will be 13266. By adding it, we get 1326. So this is the, we'll use this formula in these all the above questions. Like in the next one, second one, we have 43 cube minus 42 cube. Here the value of n is 42. The value, that is 1 plus 42 plus 1 into 3n, that is 3 into 42. This is 1 plus 3 into 3 into 42, 43 into 3 into this 5418, and by adding you get 59. And for the third part you have 67 square minus 66 square. 67 square minus 66 square, right? So we'll use the formula. The value of n here it is 66, right? So the formula is 2 into 66 plus 1. This will gives you 33. And similarly for the last one, 43 square minus 42 square, the value of n here is 42. This will be 2 into 42 plus 1, that is 5. This is the last question of Figure It Out 2 of Chapter 1. I hope you understand and get a better vision about the concepts. Thank you for watching. See you soon.